one of the oldest ideas in computation,
Which I hear that.
that artificial intelligence is this sort of clean, abstract thing, disembodied, living only in code.
Ah, right. The pure software mind.
Exactly. And our source material today, it forces us to look at a pretty fundamental shift in design thinking.
Hmm.
AI isn't just software, it's deeply and maybe even messily tangled up with the physical world,
Yeah.
with materiality.
That's absolutely right. Yeah, for too long, we've sort of treated computation as pure mind, and the materials in design as, well, just inert body.
Passive stuff.
Passive stuff, exactly. So our mission today really is to dig into how architectural design intelligence is now seen as emerging through this constant dynamic conversation, a cycle.
A conversation between what?
It's a dialogue happening between us, humans, the physical materials themselves, and the machines,
Right.
the AI and robots that kind of mediate between them.
Huh?
We are moving away from that old symbolic logic view and really stepping firmly into embodied material practice.
Okay, so let's dig into that history then, because this conflict, this mind-body thing in AI, it goes way back, right? Even before computers were uh, really powerful enough for us to debate it like this.
It really does. When we think about the origins of AI, we often think of like systems built to solve abstract problems. Tests is the classic example.
Sure.
But our sources remind us that the roots of embodied AI actually go all the way back to Alan Turing himself.
Turing. So back in 1948, he proposed this concept of a situated machine. What did he actually mean by that?
Well, he wasn't focused on abstract reasoning like chess. He imagined a machine that had like sense organs, something that would engage with the physical world around it and learn from experience.
Or like a child does.
Exactly like a child learns. The machine would be situated in its environment. And this is a really direct contrast, though maybe ignored at first, to the heavily symbolic, purely abstract tasks that, dominated early AI research, especially in the US.
So if Turing kind of laid the groundwork, theoretically anyway, it was Rodney Brooks in the 80s who really pushed it forward with something called Nouvelle AI.
Yeah, Brooks really picked up that torch and ran with it. Nouvelle AI was a massive shift intellectually. Brooks basically mandated that intelligence must be formed through situated interaction, through dealing with the physical environment.
Okay.
His team developed these embodied robots, the most famous one probably being Cog, the humanoid robot. And they were trying to prove that cognition isn't just some purely internal brain in a vat process.
Right.
It's formed through that physical engagement through interaction.
But the, let's say, conventional wisdom back then, maybe best shown by Marvin Minsky, that reinforced the exact split Brooks was trying to fight, didn't it? The mind-body split.
Exactly. Minsky's work from '86, Society of Mind, while it proposed this really distributed cognition, like thousands of internal agents of mind,
Yeah.
it was still fundamentally disembodied.
How so?
The whole system was closed off, internal. It just reinforced that old idea. Software is the mind, hardware is just the container, a passive body. For Minsky, the actual material makeup of those agents, it didn't matter. Only their structure and how they connected mattered.
So Minsky tried to keep that mind-body problem kind of neatly separated inside the machine. But these thinkers driving material AI, they're aggressively blurring that line, aren't they? They're saying the boundaries are porous.
That's the absolute critical shift. And the philosophical basis for that shift, it really starts gaining ground with someone like Andy Clark and his extended mind thesis.
Extended mind.
He argues that, look, cognition isn't just confined to your skull. It's distributed across your body and the external tools you use, including technical systems like AI and robotics.
Okay, so if I use my phone or maybe an AI design tool to figure out some spatial problem, then the tool itself becomes part of this cognitive loop, like it's temporarily integrated into how I think.
That's it, precisely. It forms a loopy system, as Clark calls it.
And that really challenges the boundary between me and not me, doesn't it?
It absolutely does. And if you connect this to the, let's say, the bigger philosophical picture, you start moving into the realm of new materialism. Specifically, someone like Karen Barad and her concept of agential realism.
Okay, agential realism.
So Barad, intelligence and agency aren't abstract concepts. They are always material practices.
Yeah.
She argues that matter and meaning are basically inseparable. They're co-constituted by what she calls material discursive practices.
Right, that sounds a bit dense. So let's translate that. For an architect working with, say, a new synthetic material, what's the practical takeaway?
The takeaway is that material isn't just passive stuff waiting for you to shape it. It's not inert.
Okay.
If you're engaging with the material is also engaging back. It has agency. And Barad uses this key term, interaction, to get at this.
Interaction, not interaction.
Exactly. Instead of thinking about separate things interacting, like human interacts with clay, she suggests that entities, whether they're human, machine, or material, they actually become intelligible. They gain their properties and agency through their physical entanglements with each other.
I think I get it. So the clay and the robotic arm molding it aren't just two separate things bumping into each other.
Right.
They become this kind of temporary co-defining system that actually creates the final form together.
You got it. That makes the material an active agent in shaping the outcome, not just some passive backdrop for the designer's genius.
Okay.
And this philosophical shift, it has really profound implications for how we even define computation and design.
Because computation, I mean, going back to Turing, it's been so rooted in language and formal logic. Right?
Exactly right. Whether it's Turing's original machine or, today's large language models, LLMs, these are all extensions of that linguistic legacy.
How so with LLMs?
Well, LLMs work by crunching massive text data sets. They optimize statistical patterns in language. It's heavily focused on syntax, on representation. It's fundamentally about the rules of communication.
But now we're seeing this really fascinating shift away from that pure linguistic heritage towards probability.
Yes. It's kind of the conceptual equivalent of that big shift in physics, moving our understanding of matter from deterministic fixed rules to probabilistic models, like quantum mechanics.
Okay.
And in design computation, AI is pushing us away from those rigid rule-based algorithms, think of early parametric design, and moving us towards inference-driven probabilistic models. These can adapt and search much, much wider possibility spaces.
And here's where it gets really interesting for design, right? Because this dramatically expands the search space for finding solutions.
Absolutely. You look at computer scientist Yoshua Bengio. He pointed out how probabilistic search methods like the ones famously used in AlphaGo beating the world champion.
Right, the Go playing AI.
That AI, it uncovered these really novel strategies that were genuinely beyond human foresight, beyond any predefined rational rules we could have programmed in.
Wow.
It shows the machine can actually surprise us with a solution we just couldn't have calculated or predicted.
Now, connecting that uncertainty, the element of surprise, back to the physical world, Rodney Brooks, you mentioned him earlier, he famously compared current LLMs to alchemy, meaning like we're seeking gold intelligence without really understanding the underlying physics, the mechanisms.
That was definitely his skeptical take on the black box nature of some AI.
Yeah.
But the design research we're discussing today, it actually embraces that idea of alchemy differently, more positively.
How so?
They define it as a kind of deep engagement with the unknown potentials hiding within materials. It's a focus on transformation that you achieve through direct experimentation, through interacting with emergent properties.
So less about waiting for a perfect rational calculation.
And more about getting your hands dirty, metaphorically or literally, and seeing what happens, what emerges.
This acceptance of the unknown, it seems like it requires designers to fundamentally change their relationship with the actual stuff they build with.
It does.
Which brings us to challenging that really old classical hierarchy of form over matter. Hylomorphism.
Yes, hylomorphism goes way back to Aristotle. It's that foundational idea that passive matter just sits there and receives an active form imposed on it by the craftsman or the designer.
Right, like a sculptor decides the exact shape and the clay just complies.
Oh, exactly.
So if I'm building a house, the hylomorphic view says I tell the brick precisely what to do, where to go. But what does someone like Gilbert Simondon say? Does the brick push back?
Simondon heavily critiqued this. He used the example of brickmaking, actually. He showed that clay isn't inert. It has active properties, energetic potential, coming through its composition, its moisture content, how it's treated, fired.
Okay.
The final form, the brick, emerges dynamically through the material's own properties and that energetic transformation. The firing, not just from the designer's plan being passively imposed.
Huh. That sounds like, well, maybe a designer's nightmare if you think about it traditionally. If the material has its own tendencies, its own will almost, we have to, as the source says, let go of the deterministic desire to control.
That is the precise goal of this kind of design research.
Yeah.
Moving toward what they call a post-anthropocentric understanding of agency.
Post-anthropocentric, meaning not human-centered.
Right. We stop seeing the material and the AI as just tools to be commanded, and instead we start viewing them as co-constitutive participants in the design process, co-creators almost.
And this thing they call messy materiality, is that the manifestation of this idea in practice?
It is, yeah. Messy materiality describes behavior that seems to resist fixed, simple rules. But, and this is important, it often reveals a deeper, more complex, sometimes self-organizing kind of order underneath the messiness.
Okay.
It's about embracing that uncertainty, and this is where the concept of aleatory material comes in.
Aleatory, like random or chance-based.
Sort of, but maybe more like processes marked by unpredictability but also emergent tendencies. Think of a natural system, maybe like how a river delta forms. The exact shape is unpredictable moment to moment, but there's an overall coherence that emerges.
So we're actually looking for productive uncertainty. We want that kind of structured unpredictability because it might extend the boundaries of design, lead to novel solutions a human alone might miss.
Exactly. And to manage this, or rather, to engage with it, the design studios involved developed a new way to work, a specific tool for this kind of engagement, the material model.
Okay, the material model. This sounds like the key innovation here stemming from this material AI perspective.
It really is.
So let's quickly set the stage. How is this different from the models architects usually make? You've got your representational models, right? The perfectly scaled little buildings.
Right, those are usually made late in the process, basically to communicate a finalized design proposal. Here's what it will look like.
And then you have performative models, like Free Auto's famous soap film models for finding minimal surfaces.
Exactly. Those are test models, study models, used to investigate specific aspects, often structural performance, trying to optimize solutions based on known rules or physical laws.
Yeah.
They're like disciplined assistants to the designer.
But the material model, this is something else entirely. It's described as autonomous. It doesn't represent a future building, and it's not for optimization.
Correct, on all counts. Here, the material itself is deliberately positioned as the active agent, as a co-creator, especially in those very early speculative stages of design.
So the designer isn't necessarily trying to achieve a specific predetermined outcome.
No, not initially. They're trying to engage with the material to see what it wants to do, what forms of behaviors it tends towards under certain conditions.
And this starts with these things called material probes, small-scale casting experiments. Can you maybe walk us through what one of those looks like?
Yeah, they're literally experiments designed to probe the material's agency. So they might combine an aggregate, maybe like cement or resin, with something else that changes state over time, like wax that melts, or salt that dissolves, or ice that sublimates.
Ah, so that introduces uncertainty right into the mix.
Exactly. The melting or evaporating element introduces unpredictability. And crucially, these probes are often conducted outside of any specific design constraints at first. They're not trying to solve, say, how to build a specific wall section.
They're just exploring.
They're just trying to understand the material's inherent structural tendencies, its organizational potential, its aesthetic qualities, when its own internal rules are pushed or allowed to play out.
And this is like a way of writing down the material's preferences. The results of these probes lead to what they call material recipes.
That's a good way to put it. The recipes basically codify the ingredients, the processes used, and importantly, the emergent architectural qualities that arise from that specific probe. Texture, structure, porosity, whatever it might be.
Oh.
And these recipes then become the foundation, the starting point for a larger architectural investigation. But maybe the most intriguing part of the whole process is how they bring this material reality back into the digital realm. They use this highly speculative technique called mismapping.
Mismapping. Okay, the sources call this an artful maneuver or a Kunstgriff. So wait, you start with a perfect, clean digital model. Then you physically cast it in the real world using one of these recipes, and the messy material inevitably changes it, right?
The physical object is never identical to the pristine digital one.
So then what? Normally you'd use photogrammetry, 3D scanning to capture that messy physical object and bring it back into the computer as accurately as possible, right? A digital twin.
That's the conventional workflow, yes.
Yeah.
Precise reconstruction. But in mismapping, they deliberately do the opposite. They capture the texture, the sort of dirty, materially influenced surface data from the physical cast.
Okay.
And they deliberately extract just that texture information.
And then they just, slap that messy texture back onto the original pristine digital geometry, the one that existed before the messy casting process even happened. That sounds like a intentional sabotage of the model.
It kind of is. It's an intentional misalignment. It completely subverts the expected one-to-one relationship, that congruence between the physical object and its digital representation.
Why? What does that achieve?
It creates this mediated relationship that they argue retains a kind of material memory, of that physical engagement, of the casting process, of the material's agency.
Hmm.
The resulting image or model isn't aiming for a realistic rendering of a physical object. It's often something quite surreal or chimeric, a graphic effect that merges the material's actual behavior with the designer's original, more rational intention. It becomes a record of that interaction we talked about earlier.
Wow. Okay, so we start with this really deep philosophical idea that matter isn't passive, that it has agency. And we end up with this, frankly, pretty revolutionary design technique that forces the clean digital model to acknowledge the messy physical reality it was briefly part of.
Exactly.
So, zooming out,
Mhm.
what does this convergence of material, AI, and these new techniques actually mean for the designer? What's the big takeaway here?
I think the core takeaway is that design intelligence itself is shifting. It's moving away from this idea of abstract control, purely algorithmic top-down design where the designer dictates everything,
Right.
and moving towards reciprocal engagement, towards dialogue. These recursive feedback loops created by processes like the material probes and mismapping, they establish a kind of shared collective intelligence in architectural practice.
An intelligence that explicitly recognizes the agency of non-human participants.
Yes, recognizing the agency of both the AI as a mediating tool and the material itself as an active co-creator.
And as we start to really embrace this collective material-based intelligence, the sources point towards one final, truly provocative possibility, something maybe on the distant horizon, a direction that pushes this material AI convergence to maybe its ultimate limit. Organoid intelligence, or OI?
Yes, this is definitely entering the realm of speculative future research, but it's out there. The idea is potentially merging AI interfaces with actual biological, neural, tissue lab-grown clusters of brain cells, often called brain organoids.
Whoa, for what purpose?
The theoretical goal is maybe enhanced biocomputing, creating these truly hybrid biological artificial systems. Now, obviously, this remains deeply speculative, incredibly complex, ethically and technically.
Hugely complex.
Hugely. But it raises this profound question that really builds on everything we've discussed today, doesn't it? If the future of design potentially involves co-creation with these kinds of hybrid agents,
Yeah.
then we really have to start considering the deep ethical implications of working alongside architectural co-creators that are, at least in part, biological, and potentially, down the line, capable of experiencing sensations or some form of awareness,
That's quite a thought. That's where material engagement stops being just a metaphor for agency.
and becomes truly fundamentally post-human. A challenging place to leave it, but that's where this line of thinking ultimately leads.